formation of stationary waves can be very well demonstrated in case of vibration of a string. Suppose if you take a string and stretch it between two rigid supports. This is a string which is stretched, it is under tension between two rigid supports. If you pluck the string anywhere, कहीं पर भी उसको pluck करो, what will happen? A wave will be generated. That wave will travel to the end. From there, it will get reflected. The wave will start from where you pluck it. जहां पे आपने pluck किया ऐसे, वहां से wave निकली. It travels to the end. It travels with what velocity? V is equal to under root T by M. Velocity of transverse wave on a string, V is equal to under root T by M, whereas T is tension in the string and M is mass per unit length of the string. Remember that? What is small m? Mass per unit length of the string, also called linear density of the string. Mass per unit length, small m, is also called linear density of the string. So when you pluck the string, a progressive wave is produced which travels with this velocity up to the end. From the end, it will get reflected. So now there are two waves, incident wave and reflected wave, and they are exactly identical. They are traveling along the same path and in opposite directions. So what will happen? Stationary waves will be formed. So you'll see loops like this, isn't it? So the formation of stationary waves can be observed on a string. So suppose a string of length L is stretched between two rigid supports. If you pluck the string exactly at the center, बराबर बीच में अगर उसको प्लग करो, तो जहां पे आपने उसको प्लग किया वहां पर क्या बनेगा? ऑब्वियसली एंटीनोड. सो वन लूप इज फॉर्म्ड. If the string is plucked exactly at the middle, exactly at the center, then one loop will be formed. In terms of lambda, how much is this? Length of one loop is lambda by 2. एक वेवलेंथ में लैम्बडा के अंदर दो लूप्स होते हैं, तो एक लूप की लेंथ कितनी है? लैम्बडा बाय 2. So when you plug the string exactly at the center, one loop is formed, means this length is lambda by 2. So lambda by 2 is equal to L, the length of the string. So you can say that lambda is equal to 2L, isn't it? So the frequency of vibration of the string N is actually V by lambda. Frequency का formula क्या है? V by lambda. You can write it as 1 upon lambda into V, V by lambda, or 1 upon lambda into V. So the frequency will be equal to 1 upon lambda. 1 upon lambda is 2L. And what is V? Velocity of transverse wave on a string, under root T by M. So the frequency of vibration of the string N is equal to 1 upon 2L under root T by M. This is the minimum frequency with which the string can vibrate. कम से कम इतनी frequency से string vibrate हो सकती है, क्योंकि कम से कम एक लूप बनेगा, आधा लूप तो बन नहीं सकता वहां पर. ये fixed end है, these two are fixed ends, तो वहां पे particles vibrate नहीं हो सकते. Fixed end है, particles cannot vibrate, means यहाँ पे node बनेगा, यहाँ पे node बनेगा, particles cannot vibrate, particles are not free to vibrate. So nodes are formed at these 2 points. और दो नोड्स के बीच में होता है एक एंटी नोड, मीन्स वन लूप. सो वन लूप कैन बी मिनिमम फॉर्म, लेस देन वन लूप, हाफ लूप यहाँ पे नहीं बन सकता. मीन्स दिस इज द मिनिमम फ्रीक्वेंसी with which the string can vibrate, and the minimum frequency with which the string can vibrate is called fundamental frequency. Fundamental frequency or first harmonic. This frequency is called fundamental frequency or first harmonic. The minimum frequency with which the string can vibrate is called fundamental frequency or first harmonic. So this is one case of vibration of the string. The same string, suppose if you support it lightly at the middle, जहां पे आपने प्लग किया था पहले, वहां पे ऐसे उंगली रखो, मतलब यहाँ पे सपोर्ट हो गया. Two segments are formed when you support it at the middle. Two segments are formed. Plug at the center of any one segment. किसी एक सेगमेंट के बीच में प्लग करो. Two loops will be formed. जहां पे आपने सपोर्ट किया है वहां पर particles are not free to vibrate. You have supported it here, so particles are not free to vibrate. तो यहाँ पर बनेगा node. You plugged it at the center. ये फिक्स एंड है नोड, ये भी फिक्स एंड है नोड. दो नोड्स के बीच में एक एंटी नोड, मीन्स टू लूप्स विल बी फॉर्म. सो इफ यू सपोर्ट द स्ट्रिंग lightly at the middle, two segments are formed. Plug at the center of any one segment, then two loops are formed. This is the next mode of vibration. अगला मोड, वन लूप के बाद दो लूप बन सकते हैं, डेढ़ लूप नहीं बन सकता वहां पर क्योंकि फिक्स एंड्स है. सो आफ्टर वन लूप टू लूप्स कैन बी फॉर्म्ड. सो दिस इज द नेक्स्ट मोड ऑफ वाइब्रेशन ऑफ द स्ट्रिंग. नाउ इन दिस केस, how much is this length in terms of lambda? It is lambda. This length is lambda. But this lambda is different from this, क्योंकि यहां पर लेंथ L में आधा लैम्बडा था, उसी लेंथ में पूरा लैम्बडा है, मतलब ये दोनों डिफरेंट है. तो इसको हम लैम्बडा नहीं बोल सकते, इसको हमने लैम्बडा बोला था, इसको हम बोलेंगे लैम्बडा 1. सपोज दिस इज लैम्बडा 1. So from this figure you can say that lambda 1 is equal to L, length of the string. So now lambda has changed, means frequency has changed, because frequency is V by lambda. Lambda has changed means frequency has changed. So now the new frequency N1, पहली frequency थी N, अब नई frequency N1 will be V upon lambda 1, that is equal to 1 upon lambda 1 is L into V under root T by M. So now the frequency of vibration of the string N1 will be 1 upon L under root T by M. If you multiply and divide it with 2, 2 से multiply किया और 2 से divide किया, this 1 upon 2L under root T by M is N, means N1 is equal to 2 times N. So the next mode of vibration, the next frequency N1 is equal to 2N. This is called first overtone. N1 का मतलब first overtone. Overtone मतलब फंडामेंटल फ्रीक्वेंसी से आगे वाली फ्रीक्वेंसी. Overtone means the frequency after fundamental frequency. N1 means the first frequency, first higher frequency after fundamental frequency. Fundamental frequencies के बाद की पहली higher frequency, first overtone. And this 2N is called second harmonic. क्या बोलते हैं उसको? Second harmonic. जैसे N have first harmonic, 2n is called second harmonic. So n1 is equal to 2n. How will you read it? First overtone. This subscript we use for overtone. N1 means first overtone. N2 means second overtone. N3 means third overtone. So N1 first overtone is equal to second harmonic. 2n का मतलब क्या? Second harmonic. Harmonic मतलब ये है first harmonic n, तो second harmonic होगा 2n, third harmonic होगा 3n, and so on. So this is the next mode of vibration. The same string, if you support it at 2 points, 3 segments are formed, as you can see. Pluck at the center of any one segment, you will get 3 loops. 3 loops will be formed. In terms of lambda, how much it is? एक loop मतलब होता lambda by 2. So lambda by 2, lambda by 2, lambda by 2, that is 3 lambda by 2. And again, this lambda is different from these two, तो उसको हम बोलेंगे lambda 2. So 3 lambda 2 by 2 is this length. So 3 lambda 2 by 2 is equal to L, or you can say lambda 2 is equal to 2L by 3. So now the new frequency N2 will be equal to 1 upon lambda 2, यानी कि 2L by 3 into V, that is under root T by M. So N2 is 3 upon 2L under root T by M. देख लो एक बार बराबर है क्या? ऐसे जैसे हमने फर्स्ट 2 केसेस में किया वैसे ही. Lambda 2 is 2L by 3. So N2 will be V by lambda 2. Lambda 2 की जगह पर 2L by 3. V की जगह पर under root T by M. What is this? 1 upon 2L under root T by M is N, means N2 is equal to 3N. So N2 is equal to 3N. This is the next mode of vibration. Second overtone is equal to third harmonic. Second overtone is equal to third harmonic. Second overtone मतलब फंडामेंटल फ्रीक्वेंसी के बाद की दूसरी फ्रीक्वेंसी. N1 फर्स्ट ओवरटोन मतलब फंडामेंटल फ्रीक्वेंसी के बाद की पहली फ्रीक्वेंसी. N1 फर्स्ट ओवरटोन, फंडामेंटल फ्रीक्वेंसी के बाद की दूसरी फ्रीक्वेंसी N2 सेकंड ओवरटोन इज इक्वल टू थर्ड हार्मोनिक. इसका मतलब फर्स्ट हार्मोनिक N, सेकंड हार्मोनिक 2N, थर्ड हार्मोनिक 3N, फोर्थ हार्मोनिक क्या होगा 4N, फिफ्थ हार्मोनिक 5N. इज इंटीग्रल मल्टीपल्स ऑफ N. हार्मोनिक्स का मतलब क्या? इंटीग्रल मल्टीपल्स ऑफ N. N multiplied by 2, N multiplied by 3, N multiplied by 4, N, 2N, 3N, 4N, 5N, 6N, 7N, 100N, 2000N. इंटीग्रल मल्टीपल्स हार्मोनिक्स मतलब. So second overtone N2 is equal to 3N. So what do we mean by harmonics? The fundamental frequency N and all of its integral multiples. Fundamental frequency together with all of its integral multiples. मतलब fundamental frequency N और उसके सारे integral multiples 2N, 3N, 4N, 5N, 6N, 7N, 8N, 9N, 10N and onwards are called harmonics. The fundamental frequency together with all of its integral multiples are called harmonics. And first harmonic in case of string N is 1 upon 2L under root T by M. First overtone is equal to second harmonic. Second overtone is equal to third harmonic, and so on. If you consider the first harmonic means formation of one loop. Suppose one loop is formed, that is first harmonic. Then how much is this length in terms of lambda? it is lambda by 2. And suppose length of the string is L. Means lambda by 2 is equal to L, or you can say lambda is equal to 2L. When one loop is formed, means first harmonic, then lambda is equal to 2L. If you consider second harmonic, means formation of two loops, this length is L. In terms of lambda, it is lambda. Means in this case, lambda is equal to L. When one loop is formed, wavelength is 2L. When two loops are formed, second harmonic, wavelength is equal to L. When three loops are formed, then lambda by 2, lambda by 2, lambda by 2, that is 3 lambda by 2 is equal to L. Means how much is lambda? 2L by 3. So for the first harmonic, formation of one loop, lambda is equal to 2L. Lambda is equal to 2L, or you can say 2L by 1. 2L means 2L by 1. So for one loop, for first harmonic, lambda is 2L by 1. For second harmonic, two loops, lambda is L, means 2L by 2. Chalega? L can be written as 2L by 2. Means for two loops, for second harmonic, wavelength is 2L by 2. For three loops, three harmonics, third harmonic, lambda is 2L by 3. Observe it. For one loop, lambda is 2L by 1. For two loops, lambda is 2L by 2. For three loops, lambda is 2L by 3. Means lambda is 2L upon number of loops. Right? In general, lambda is 2L upon number of loops or harmonic number. क्योंकि number of loops is same as harmonic number. First harmonic में कितने loops होते हैं? One loop. Second harmonic में कितने loops हैं? Two loops. Third harmonic में कितने loops हैं? Three loops. Means in general, lambda is equal to 2L upon number of loops or harmonic number. Let's call it suppose P. P is number of loops or harmonic number. So in general, lambda is equal to 2L by P. In case of vibrations of a string, we are talking strictly about the string. In case of vibrations on a string, the wavelength in general is 2L by P, whereas P is the number of loops or harmonic number. So in general, N is 1 upon lambda into V. So N is equal to 1 upon lambda means 2L by P, 2L by P, and V means under root P by M. So this is the general formula for frequency of vibration of a string. N is equal to P upon 2L under root P by M, whereas P stands for number of loops or harmonic number. So for first harmonic, P will take as 1, means N is 1 upon 2L under root P by M. For second harmonic, will take P equal to 2, so N will be 2 upon 2L under root P by M, 2M. For third harmonic, will take P equal to 3, so N will be 3 upon 2L under root P by M, 3N, and so on. So this is the general expression. N is equal to P upon 2L under root P by M, whereas P stands for harmonic number, or you can say P stands for number of loops on the string. So that was different modes of vibration of a string. Rest of the things we shall see now in the next lecture. So have a nice time. Good day. Bye bye.